Hi everyone. In this session, I want to discuss about the four variable K-map. Four variable K-map. So here, for four input variables A, W, X, Y, Z. For four input variables, there will be 16 minterms. 16 minterms. That is 2 to the power of 4, that is equal to 16 minterms. 16 minterms. For 4 input variables, there will be 16 minterms. So, here each minterm specifies in each square in the K-map. Each minterms specifies a square in the K-map. So here the arrangement of minterms in four variable K-map consists of 16 squares. Each minterm specifies a square in the K-map, and hence this four variable K-map consists of 16 squares. 16 squares. So 1, 2, 3, 4 and up to 16. So this K-map is arranged in the 16 squares. So the arrangement of minterms in this K-map is like this. So the first minterm M0 is arranged here, M1, M2, M3, M4, M5, M6, M7, M8, M9, M10, M11, M12, M13, M14, and the last minterm is here. This is the representation of 16 minterms in four variable K-map. The four variable K-map consists of 16 minterms. Each minterm specifies a square in the K-map. So here the first minterm is specified here and the last minterm is specified here. M0, M1, M2, M3, M4, M5, M6, M7, M8, M9, M10, M11, M12, M13, M14, and the minterm, last minterm is specified here. This is the format representation of four variable K-map. Four variable K-map. Now, what is the relation between the squares and variables? Now we are going to see the relation between the squares and the variables. So here it consists of this four variable K-map consists of four variables W, X, Y, Z. So here the first two variables are taken in rows and the remaining minterms Y, Z are taken in columns. Now here this arrangement is similar to the Gray code. The arrangement of minterms in this K-map, in this squares are arranged like Gray code. Here what is Gray code means? Only one bit will change from one column to the next adjacent column. Only one bit will change from one column to the next adjacent column. That is the Gray code, not a binary sequence. So this arrangement is made in Gray code, similar to the Gray code. So here this is 0, 0, 0, 1, 1, 0, 1. In the same way 0, 0, 0, 1, 1, 0, 1. This is the Gray code arrangement. Here it consists of two variables and minterms with two variables 0 0. One bit will change 0 1. Only one bit will change 1 1 1 0. And in the same way the rows arrangement in gray code. So here the first minterm M0, M1, M2, M3, M4, M5, M6, M7, M8, M9, M10, M11, M12, M13, M14 and the last minterm is specified here. This is the representation of minterms in the K-map. 4 variable K-map and each minterm specifies a square in the K-map. So here this is the first minterm M0. What is M0 here? W bar, X bar, Y bar and Z bar. W bar, X bar, Y bar, Z bar. The second minterm W bar, X bar, Y bar, Z. W bar, X bar, Y bar, Z. Third minterm W bar, X bar, W bar, X bar, Y, Z bar. Y, Z bar. Here the fourth minterm M3. W bar, X bar, Y, Z. M4. M4 is here. M4. W bar, X. W bar, X, Y bar, Z bar. And the fifth minterm, W bar, X, Y bar, Z. Y bar, Z. Next, sixth minterm, W bar, X bar, sixth minterm, M6, W bar, X, Y, Z bar. Next, seventh minterm, M7, W bar, X, Y, Z. X, Y, Z. Eighth minterm is specified here. Eighth minterm, W, X, bar, Y bar, Z bar. Ninth minterm, M9, W, X bar, Y bar, Z. 10th minterm is specified here. 10th minterm, what is 10th minterm? W, X bar, Y, Z bar. 11th minterm, next here, 12th minterm, W, X bar, Y, Z. 12th is specified here. W, X, Y, Z bar. M30, 14th minterm, W, X, Y bar, Z. 14th minterm, W, X, Y, Z bar. And the last minterm, W, X, Y, Z. X, Y, Z. This is the relation between the variables W, X, Y, Z and squares. Each minterm M0, M1, M2, M3, each minterm specifies a square in the K-map. Here, this arrangement is similar to the gray code. Not a binary sequence. So here, this is W. W means 1. 1 is the true value and W bar. This can be considered as W bar, W complement. And this is the X. X is the true value. This is the X. X bar, X bar. This is the X complement. These two are the X complement. And this is the Y. And Y complement. These two can be considered as Y complement. And this is the M9 and M11 Z, and these two are the Z complement. This is the representation of minterms. This is the representation of minterms in each square by using the Gray code method. So here, what is the, let us take one example for the simplification of 4 variable K-map. So suppose for the function of, for the Boolean expression Wx y bar z plus Wx y bar z and plus W x y bar z bar. Let this is the Boolean expression. How can we represent this Boolean expression in the K-maps? Here, what is K-map? K-map is the pictorial representation of truth table or expression. So here, this expression can be represented by using this K-map. So here, Wx y bar z. What is Wx y bar z? Wx y bar z. Wx y bar z. This is the Wx y bar z. M3, M30. This is 1. And Wx bar y bar z bar. Wx bar y bar z bar. Wx y bar z bar. Wx y bar z bar. M12. This is Wx y bar z bar. M12. So this is the representation of Boolean expression in the K-map. So the remaining are 0 and no need to specify. So here in the 4 variable K-map, the top and bottom squares or bottom cells, left and right minterms, left and right squares or minterms can be taken as adjacent cells. This is very important. So here in this 4 variable K-map, the top and bottom squares, this is the top and this top and bottom squares can be considered as one cell. So here the left and right squares can be considered as a minterm, adjacent cells. So while grouping the K-map, while grouping the cells, this is very important point and that we'll discuss later. So here in this 4 variable K-map, it consists of 16 minterms and each minterm specifies a square in the K-map, and this is the representation, this is the format of 4 variable K-map, and this is the relation between the squares and the variables of the 4 variable K-map. That is about the 4 variable K-map. Okay, thank you.